Another example, when you heat water, so we're heating it now, as the water is heated, there are more ways for the energy to be arranged because we're adding more bits of energy. But if there are more ways, it becomes more disordered, which is good, which means a greater entropy. So this is what you would expect. Now, if we have some boiling water that we're still heating, as the water boils, there become fewer particles because they start to evaporate. Now, since you have a certain number of particles with the same average kinetic energy because of the same constant temperature, but there are fewer of them, it means there's less space, less energy, so it will be more ordered. So how is that possible? How is the entropy reduced here? But it's not, because when it evaporates, a lot more particles and a lot more energy is released to the surroundings. As they spread out, there's much more disorder. So that overall there'll be an increase in entropy. Let's take this example. Hot water. As the water cools, there are fewer ways for the energy to be arranged. This means less disorder, which means entropy goes down. But entropy must increase. But we know it increases because when it cools down, the energy goes to the surrounding bodies. So even if the entropy decreases locally, the total entropy in the universe must increase. A heat engine, the heat will flow from hot to cold. So we know that the energy spreads out, so entropy increases as the energy degrades. What about a heat pump? How do you manage to get heat to go from cold to hot? In other words, it becomes more ordered if it goes from cold to hot. In other words, you decrease the entropy. And the answer is, in order for that to happen, you must do work to get this to happen. It doesn't happen by itself. So there has to be some agency at work which is going to move the thermal energy from cold to hot. And if that happens, then in doing that, entropy must be increasing somewhere else in the universe. So the overall level of entropy must increase. What about your tidy room? How does your room get tidy? Well, its natural state, I think you should tell your parents, is actually one of disorder, because there are many more ways for it to be disordered than there are for it to be ordered. So how do you get a tidy room? Well, you have to do work to make it tidy. It doesn't happen by itself. So you should go home and get on with it. There's this thing called Maxwell's demon that we can't see quite clearly there. And that's that we have this two gases, a mixture of black and white particles, evenly distributed. Now, Maxwell's demon said, and this is what Maxwell suggested, if there was some way that you opened the gate to allow the black coloured balls to go to the right and the white coloured balls to go to the left, then you would get an increase in entropy, a decrease in entropy because it becomes more ordered. So he said that this is possibly an example where entropy would decrease. Notice that it says it's a friction-free trapdoor, so he doesn't have to do work to open it. But the failure with this is that it was recognized that in order for this to happen, he would have to observe where the particles were to be able to know when to open the door. And that observation uses up energy. There's a photon that arrives on his eyes where he observes it, and therefore that uses energy. Another example. This is quite easy. You know that an ice cube is a tight structure. There's very small entropy and is maximum order. So what happens with time, it melts. So the disorder increases and we have a maximum entropy. What happens on a very cold day? It's the same thing but in reverse. Now, how do we get from this state of maximum entropy, in other words minimum order, to a state of minimum entropy in maximum order? This is entropy going the wrong way. Well, the fact is, if there's a reduction in entropy here, it must mean there's an increase in entropy elsewhere. And as you know, that when ice is formed from water, we have this thing called the latent heat. We know that some energy will be released as these bonds are made, and so that is released as heat. So in the universe, the entropy will be increasing.